Today we're going to solve linear equations. So how do we solve linear equations? All we do is isolate the variable. For example, all we need is x equals a number. That's our goal. Okay, so we want to solve for x. We could try to get rid of the 3 first, but then you'd have to divide everything by 3. And in this problem, it's not a big deal, but a lot of times that results in a fraction. So we'll get rid of the 6 first by, what we're going to do is we're going to subtract both sides by 6, and they cancel, and then we're left with 3x is equal to 6, and then we could divide both sides by 3. X is equal to 2. You can always check your answer by plugging it in and see if that answer, that solution, results in a true statement. So 3 times 2 plus 6. 3 times 2 is 6 plus 6, since that's true. Yep. So this one looks very similar, but there's a placement of parentheses in there. Let's see what that does. Now, we want to get rid of the parentheses first before we isolate the variable. We could distribute it using the distributive law, but we could also just divide both sides by 3. Since it does divide into 12 evenly, that's the way I'm going to do it. If it didn't divide in there evenly, I would distribute it. But so what we can do is divide both sides by 3. Since that's 3 times x plus 6, you only divide, we don't have to distribute it. Then we're left with x plus 6 is equal to 4. We can subtract 6 underneath it if we want, but just be careful to make it look like divide. X is minus 2. So we've got a different solution, and we can, again, check it. 3 times minus 2 plus 6, does that equal to 12? You have to do parentheses first. And it certainly does look like that's our solution. So to do this problem, we want to get rid of our fraction. We can multiply both sides by 5. You can multiply both sides by the reciprocal and get it done in one step, but I like to do it one step at a time. And that goes in there 7 1/2. Okay, to solve this equation, this has 2 y's on it. So what we need to do is get it into the form we're used to, and let's take care of that y first, that's on both sides. So we want to add or subtract one of the y's to the other side. It's probably easier. You don't always have to bring it to the left. But if I add y on this side of the equation, I add y on this side of the equation. And over here, they minus y plus y cancel. I'm left with 28. And this side is 6y minus 2. And then we're back to our comfortable form of adding 2 and then dividing by 6. So we can add 2 to both sides. And then divide by 6 on both sides. And that isolates the y. What we want to do is, again, I don't like the fractions very much, so I'm going to take the equation, I'll copy it, and we multiply on the right side. The common denominator that will clear that fraction will be 6. So your LCD between 3 and 6 is 6, because they both divide into it evenly. And then on this side, and I will be distributing it. So it's 6 times 2/3 x minus 1/6 times 6. And 2x times 6. So you can see here, we could have just multiplied 6 to each term. It's the same thing. So now we do the math. 3 goes into 6 2 times. 2 times 2 is 4x. Or you could look at it. 6 times 2 is 12. Divided by 3 is also 4. Either way, these cancel. It's minus 1. The 1's left. And this is 12x. And now we have an x on both sides. Again, we can subtract the 12x over to the left and then add the 1 to the right. We don't have to do it that way though. We can be adventurous and subtract 4x on both sides. I'm left with minus 1 equals 8x. And then divide by 8. And I get x equals negative 1/8. And if you want, if that bothers you, you can rewrite it like this. Same answer. So another type of equation is you don't have numbers in them at all. So we will just solve for one variable in terms of all the other variables. So since x is what I want to solve, we'll get rid of the b first by subtracting it, and then we'll divide by m. So it'll be y minus b equals mx, because I'll subtract b on both sides like so, and that cancels it. And then divide both sides by m. And I've isolated the x on the right side, but I can write it on the left side. We can write it like we see it, or we can distribute that m, y over m minus b over m. Either way is correct. They're both good answers. Okay, here's another one to solve. So we have 2x minus 5 on the right. We want to get rid of the parentheses first. So we distribute 2x minus 6. And we have a 2x on both sides. So what's going to happen when we subtract 2x on both sides of the equation? Cancels over here, I get minus 6. Over here it cancels also, and all my variables disappeared, and what I'm left with is a false statement. Okay? So a false statement means that there's not going to be any solution. There's no solution. Let me explain why. It means I can't find anything. It means nothing that I can plug in will yield in a true statement. Let's look at the previous 2x minus 5, 2x minus 6. Before we subtracted off 2x, these are equal on both sides. And then if you subtract 5 from one side of that and 6 from the other, nothing you plug in will ever give you a true statement. So when your variable disappears, two things can happen. When you subtract off your variable, you'll either get a true statement or a false statement. If it's a false statement, like you see here, there's no solution. Okay, that's the answer. There's no answers. Okay, so here's another example. So we definitely want to clear our parentheses here. So we distribute a half. Half of 4 is 2x. Half of 6 is minus 3. And on the left, I have 2x minus 3. Now, we can go and try to isolate our variable, but look at both sides. We have 2x minus 3 on the left, 2x minus 3 on the right. They're identical. It's kind of like an identity. We can go further if we want. If I subtract 2x on both sides, I get minus 3. That goes away too, equals minus 3. Again, this is a true statement. This is true. Therefore, solution is all reals. So anything I plug in, I multiply by 2 and subtract 3, I get a true statement every single time.